Hello and welcome to my channel. In this video, I'm hoping to show you how to create a simple 2D platformer player controller script. And in my scene I have already set up, I have a player game object, which I attached a rigid body 2D object to. I made a special material called slippery bounce, which if you look at it, you can see the friction is just really low and a little bit of bounciness is added. To make this material, all you have to do is right click and go to create and physics material 2D. And then you can enter in the same values I have here to get the exact same result. Along with that, I set the collision detection to continuous and I froze the Z rotation under the constraints. I also have a sprite with this test sprite I made and a collider object with a box collider so we don't fall through the floor. Hey everyone, this is editor Michael here, and I have one more thing to add. I have on my collider object for my player, I have it tagged as player collider. To do this, you just have to go here to add tag, click the plus button, and you just can call it player collider. Then once that's created, go back to your collider and set the tag. For the ground, I went ahead and created a simple tile map, added a tile map collider, added a rigid body 2D, set it to static, added our slippery bounce material, and added a composite collider 2D and checked the used by composite tile map collider 2D option. Now with all that set up, all we have to do is select our player, click add component, and we can add a new player movement script. And then I'm just double clicking it to open it in Visual Studio. Now that we have our script open, I'm going to go ahead and remove all of the update and start functions. We might need those later, and we'll bring them back if we do. The first thing we're going to want to add is a private rigid body 2D. I'm just calling that RB. And to make sure we get our rigid body, I am going to add the awake function. And inside awake, I am just setting RB equal to get component of type rigid body 2D. And this will get the rigid body component that we have on our game object that has this script. Next thing I want to do is I will add a private Boolean, and I will call it can jump. And I'm just going to set it equal to true by default. Then I have a couple lines where we're going to want to serialize the field. Go private, float, movement speed. I'm just going to copy this line and I will rename this jump speed. The reason I serialized the fields is because since they're private, that means that other scripts can't access them. But if we serialize a field, then we can view them inside of Unity. Another way to do this is to just make them public, and then that way other scripts have access to them. But I just do this to make it a little neater. All right, now I'm going to go ahead and add our update. And inside of here, I'm going to go ahead and add a function called movement, and we'll go ahead and create that. And go private void movement. And then I'm going to do all our coding for making the player move inside of this function, which will be called every time update runs. So first, to get the player input, I'm going to go ahead, make an if statement and check if input dot get axis raw, and we'll be checking the horizontal axis because it is a 2D platformer. So I'm really only checking if the player is moving left and right. And we'll check if that's greater than 0. Then I will change the rigid body's velocity and set that equal to a new vector 2. And in this vector 2, the x value will be the movement speed multiplied by time dot fixed delta time. And the y value will be just the y value of velocity at the moment. The next thing I'll want to do is add an else if statement. So else if input dot get axis raw of the horizontal axis is less than 0. And we can just copy our line from before and just add a negative sign before the movement speed. And then of course, we'll want to go else. And this is if no key is being pressed, then we don't want our player to keep moving. So we'll go, actually, we can just copy this line and set that equal to 0, add an R, and I believe that should be it for the horizontal movement. We can go ahead and save what we have, go back to our game, and let's see, what's a good value? I'll try 150. I'm going to go ahead and run. If pressing the right key, I go right. Pressing the left key, I go left. And currently we do not have any jumping, so let's go ahead and add that. One other thing I wanted to touch on, the reason I'm using get axis raw here is because if you use just get axis, then there is a slight delay between the time when you release the key and when the player stops moving. But if you use get axis raw, then for whatever reason, when you let go of the key, then the player immediately stops moving. So now we're going to go ahead and add jumping. So in our update, I'm just going to go ahead and add a jump function call. We can go ahead and create a jump function. So I'm going private void jump. So before we get started adding stuff to the jump function, I'm going to define a few more things up top. For this jumping, I am going to use a raycast or a couple raycasts to determine whether or not we are actually on the ground. So I'm going to add a few more variables up top to define that. So I'm going to serialize the field, private, float, call it ray length. Do that again, serialize the field, private, float, ray position, offset. And what these two variables are going to do is the first one, ray length, is going to determine how long of a ray we should cast. And ray position offset is going to be used to offset the 3 rays that we're going to use to determine if we are on the ground. I'm going to also set up a couple vector 3s here for the ray position. So I'm just going to call it ray position center. I'll copy that 2 more times. do ray position left and ray position right. I'm going to define a raycast hit 2D array and call that ground hits center. And what we can do for that is also just copy and paste it. And we can call this ground hits left, ground hits right, and then we can do another raycast hit 2D array, but I'm making an array of, of the arrays and just grouping them all together and calling it all raycast hits. I'm setting that equal to a new raycast hit 2D, setting the length to 3. And what that'll hold is just all of these lists so I can iterate through all of them in a later function. So now that we have everything defined up here, I can go back down to jump and go ahead and set up ray position center to be equal to transform position plus a new vector 3 with the 0 in the x position, the ray length, I'm just multiplying that by 0.5 just so the ray moves up a little bit, and then 0 for the z. And I'm going to go ahead and copy that line and paste it 2 more times. And then I can do left and right. And what I want to do is change the x so it is minus the ray position offset. And then for the right, I am just going to enter the ray position offset, but positive. So that way those two rays are equidistant from the center ray. And the reason I'm setting it up like this is because if your character is a little wider and they're standing on a ledge, that center raycast could be over the ledge. And even though your player is on the ground technically, they wouldn't be able to jump because that ray wouldn't be touching the ground. So that's why I have these 2 other raycasts. Next up, I'm going to want to go ahead and define our ground hits center. And to do that, I'm going to set it equal to physics 2D dot raycast all at ray position center negative vector 2 dot up, so it's pointing down, and I'm going to set the length to be the ray length. And like we've done before, we can copy that line and paste it 2 more times. Go ahead and call this ground hits left and ground hits right. Let's make sure we update our position to the ray position left and ray position right. Next, I'll need to combine all of these raycast hits into our double array for all raycast hits. So, just so I don't overcomplicate it for myself, I'm just going to say all raycast hits at 0 will equal ground hit center. Then I can copy and paste that line 2 more times. All raycast hits 1 and 2 be equal to the left and right. Then what I'm going to say is can jump is equal to a new function we'll have to create called ground check. And for ground check, I am going to pass all raycast hits, and it will return a Boolean determining whether or not we can jump. So let's go ahead and make that ground check. All right, so I'll go ahead and make a private bool function called ground check. And we are passing in a raycast hit 2D array. And I will call that ground hits. So first thing I will want to do is to loop through each object in ground hits. So I am going for each raycast hit 2D array. I'll call it hit list in ground hits. And then we'll want to do another for loop. So we can go for each raycast hit 2D hit in hit list. So now we're actually looping through each time a ray hits something. If hit.collider is not equal to null, and then inside that, I'm going to do another if statement. If hit.collider.tag is not equal to player collider, then we'll return true. If we get through all of the hits for all of the raycasts and they're not touching anything aside from the player collider, then we will return false, because that means that the player is still in the air. So now our ground check will return a bool, either true or false, telling us if we can jump. And we're storing that in this Boolean called can jump. One more thing I want to add to the jump function. It's not entirely necessary, but it might help you see what we're actually doing. So I'll go ahead and write it out for you. So I'm doing debug.drawRay. And I will just copy this part of our ground hit center. And I'm going to multiply our negative vector 2 up by our ray length. And I'm going to color this red so we can see it. And I'll just do this for the other two as well. For our other two raycasts, left and right. And what this does is it'll show you in the game where we're drawing those rays, so you can see what it's actually interacting with. So if we want, I'll just save this and we can go back to our game. And for our ray length, go ahead and make it 1. Our offset, I'll make it 0.45. Jump speed, I'll make it 12.5, I think. Although we don't have any code to jump, so that won't work right now. But this will just show you how the raycasts are working. So if we run our game and we click on gizmos, you can see underneath the player, we have these 3 rays, and that shows you where we're checking for the ground. So ray length is actually pretty long. It goes down pretty far. So I'll actually go ahead and make that like 0.33, I think is okay. So go ahead and change that. And now we can go back to our code and finish up our jumping mechanic. So I actually want to go back to our movement function and add an if statement. And we can add if input dot get key code dot space and can jump. So this is checking to see if you hit the space bar and you are able to jump based on what we did before with our ground check function. Then I am going to take our velocity, make a new vector2. I will set the x value to our x velocity and zero out our y. That way, if we're falling, then our y velocity gets canceled out before we actually add some jump speed. So next line we can do our b dot velocity equals new vector2 in the x. For the x value, we will set it to rb dot velocity dot x comma jump speed. And we should be able to save this and go and jump using our character by pressing the spacebar. All right, I'm just going to turn our gizmos off for a second. We can move left, we can move right. When we jump, we go up and we come back down. So something to note here is I actually have the gravity scale set to 2. So the player comes down a little further or faster. And the reason I did that is because typically in games like Super Mario Brothers, you'll see it referenced. Mario actually falls faster than he jumps up. And the worst thing you could have for your game is probably a floaty jump. Right now, the jump is a little floaty. So let's see, we can play with these values and get it to a place where we actually like it. So I'm going to set the gravity scale to 5, mass to 2.5. I think the jump speed to 20. And that should give us a little more heft. And we fall down a little more. And the way we program this, if you hold down the space key, you actually jump. You can see we're not sticking to anything. And this code could easily be modified to add some coyote time. So like if you're in the air, you can jump a little bit afterwards after you left the ground, or you could add in a count system for how many jumps you want the player to be able to have before they don't have any more. That's really up to you. If you would like to see me go more in depth in this, leave a comment. But other than that, you should now be all set up with your simple 2D platformer player controller. Thank you for watching, and if you like this kind of video, leave a like and a comment telling me so, and feel free to subscribe.